Good morning. It's the second day of the virtual conference, the GS UK virtual conference. It's 10 o'clock, and I know we don't have many attendees at the moment, but I think we will go ahead and start. Otherwise, we may run out of time, Ravi. So if you have any questions, as we're a small group, I'm going to allow you to unmute yourselves, but Ravi has asked that you ask questions at the end of the presentation, please. Feedback. It's really, really important to us that you give us some feedback, please. We want to know what we're doing right and what we're doing wrong. And likewise for the speaker, it's always beneficial to see what people like and don't like. So today, or right now, this session is 8G. The title is X'6A BCPii Integration with OPSMVS. And we're very lucky to have our presenter Ravi Gao from Broadcom in Singapore joining us now. And with that, I'm going to hand over to Ravi. Thank you, Ravi.
Thank you, Angie, and good morning, good afternoon, and good evening to, because I don't know from where you guys are joining, but I wanted to make sure that your time is worth spending on this session. So today I'm presenting X'6A BCPii integration with OPSMVS. And just to give you a little background on the X'6A is in decimal 123, which is correlate to the SMF record type, which get recorded for the BCPii component of this US. Before I go over to the next slide and start the session, I wanted to give a quick little background about myself. So I comes with 2 decades plus experience on the mainframe, been on this US sysprog role for many years, and have done storage and capacity planning as well. And this subject is pretty close to me because it covers almost all the domains where I have experience with. So with that, with this session, I wanted to cover the agenda, which is on the slide. So talk about what is ZOS BCPii and how it is important. What you can do to have a seamless integration with the BCPii version 2, and I'll explain why do I have the version 2 listed on this agenda. Hardware and software requirement for BCPii version 2. What sort of minimum hardware and software is required for this functionality to be enabled. Then it will be following with how it can be integrated with the OPSMVS and can provide the benefit in your day-to-day operation sort of roles. Then it will have how you can enable the API role. So some of the people who comes with the OPSMVS background can probably relate what this API rule is, but I'll probably give you some snapshot on how they look like. And then OpsRex, host environment, some of the commands which you can put in your Rex environment, OpsRex environment to leverage or exploit the functionality which get provided through the BCPii. And the last two are quite important to just give you the correlation between what get presented with the topics here and how you can make it in the real life scenarios, how you can use them. But those are not just the limited cases. You can have your own one, but that should give you a little bit of idea behind how you can leverage the OPSMVS BCPii functionality. And then in the last course, we just wanted to wrap up with the summary. So what is BCPii? It's as it's a ZOS based component, and the address space which gets started with the IPL. You need not to configure it or do much about it to get started. This is the ZOS base function which gets started with the IPL. And what it does is it provide uh, the functionality to manage the interconnected hardware resources. To give you the snapshot, like what you see on the picture here is one of the LPAR, um, which is you have it defined in the CPC environment, which is a channel complex, and the BCPii function, which is a base ZOS component, give you the capabilities to have the interconnected view for all of the CPCs which are in the environment. So the OPSBCPii here is acting as an application which can gather the information from the hardware resources and any interconnected hardware resources which is available in your complex environment. Um, of course, you need to have those application authorized, and if they are authorized, you can programmatically interact with any of the hardware environment which exists in this complex. Now, some of us might be asking, what can you do using this BCPii function? Is of course using this BCPI application, you can query, you can change, you can update any of the CPC attributes which may be related to the CPC itself, or it may be related to the images which has been defined on the CPC. One of the typical example of exploiting this BCPii feature is to upgrade or downgrade the capacity, which what we call it as a on-demand capacity upgrade or downgrade. But that's not the only function, but there's many other things which you can do using this BCPii functionality. Now, you can communicate directly with the support element. So support element is one of the, if you come with the sort of a hardware mainframe background, this is a small laptop which is attached, which is within the hardware itself. If it is a Z16 box, it's going to be inside in the box itself, which is where most likely the people who come from the hardware does the activities in terms of bringing the chip in online, offline, or any sort of a function which they have to do for the hardware on the machine itself. Now, how seamless integration you can do with the BCPii version 2 is what I was explaining. When initially with the Z9 box, the BCPii came in, we were having the assembler APIs, which were provided by the IBM. However, now we don't have the BCPI version 1 that popular, and there's no functionality or the changes are being done by the IBM in the version 1 API. So the OPSMVS, which is the automation suites of the product from the Broadcom, has been supporting the both version, which is BCPI version 1, which, as I said, exploit the assembler APIs. However, version 2 has been upgraded, or the changes has been done drastically, where it does provide you the REST API sort of services. So the OPSMVS allow you to use both version 1 and version 2. Either you can enable one of them, or you can use both of them as per your choices. Now, there's some requirement which comes with any sort of a product, or feature which get enabled on the mainframe environment. So for this feature to be enabled, you need to have minimum of IBM Z15 box, which is obviously a couple of years back and fairly been known or exists in the in every customer environment. If not, somebody doesn't upgrade, that's a different scenario. But IBM recently has come up with the Z17 itself, with the announcement. So going back on the hardware requirement, we need to have a minimum of Z15 on the hardware side. For the software, you need to have minimum of version 2 release 4 or higher, which includes, even version 2 release 5 or 3.1. If you're running still with the version 2 release 4, which is highly unlikely, you need to have the APAR OA60351 to be applied to exploit the BCPii version 2 REST API features. For the support element in the HMC, there is a microcode level which is required, and it's P46598, which is a bundle S38. And for the HMC, it's 46686 bundle H25. And these are the minimum one which is required in the environment to get BCPI version 2 enabled. Now, for the coexistence requirement, you may have a complex where you have a mix of the machines where you might be having some Z15, some are Z16 CPC, and that's where it makes the complex. So you have to be a little aware about coexistence requirement as well there, which is minimum for the OPSMVS. You need to have a PTF applied, which is LU03137, and for the common services, you need to have LU 01961. Now, some of us might be asking how OPSMVS integration with the BCPii, which is the ZOS core component, can provide the benefit. So before we drill it over to the benefits, how it get integrated with the BCPii is that OPSMVS, main address space, run a child address space underneath it, and that's how it integrated. So it's called a CSRF, which is a common services component, but it common shell component which it exploit to use the BCPii functionalities. Of course, it with the integration of the OPSMVS with the BCPii, it gives you the great flexibility in terms of modifying or changing any of the parameters dynamically. And it also does accept the commands, which can be easy to code and easy to maintain as well. Now, on the benefit side, you can use this functionality to capture the hardware and the software events, and those hardware and software events can be sent over to the ops log, which is sort of a syslog in terms of if you look at this mainframe system or the LPAR, syslog is what capture all of the activities which is happening on the system, whereas ops log is um, kind of course, adding the syslog messages on top of any other operation which is being performed by the ops MVS will be captured in the ops log as well. Now, using since those events, irrespective of whether they are hardware or the software, they are coming over to the ops log, it gives you the great flexibility in terms of automating some of the operations which you may have to do manually, or which you may not be aware of in terms of who is logging on, or who is performing what sort of action on those hardware components. So using the AOF, you can, since those events are coming back over to the ops log on the software side, you can perform any of the automated tasks like on-demand capacity upgrade when and where it is required. You can also, it does allow you to query and set any BCPii attributes and issue BCPii commands from the ops log rex address HWS host environment, and you can maintain the repository and perform the data analytics. So to give you a context behind this line, of course, there may be the situation where the support or the technicians are making the changes in the attributes on the hardware components, and sometime you like to make sure those attributes, whatever is changing, is being captured and uh, being kept somewhere so that you can perform some sort of a data analytics to see what has been changed, when it has been changed, and with what value it has been changed. So those attributes can be captured back over to the when I say repository, it can be a data set, or you can have any other sort of a repository, which can be a vsam data set, or it can be a, in fact, db2 as well, where some of the customer keep it for the longer duration so that they can perform the audit as well. It also gives you the single point of view for all of the events which are happening across the CPC complex. So as I said in the beginning of the presentation, you may have one CPC which is hosting all of the LPA, but there may be other CPCs which is within the same complex, and you like to have a single point of capture for all of the events which is happening in the CPC complex. So that's also one of the benefit which comes with the integration, with the OPSMVS. Now, how it get activated on the OPSMVS side is when the BCPI API rules for the HWS messages comes over to the the uh, the ops log. There are some generic APIs which can be coded. Like on this screen, you can see there is a rule name which is HWS API, which is for the hardware messages. So any of the events which is occurring or happening on the in the CPC complex can be sent back over to the through the ENF68, which is how it get those events back over to the mainframe LPAR, and using these generic API rules. Based on how you code it and what kind of code you have, you can capture them and perform any action, which may be either alerting the designated team, or performing some automated functions. Now, these are some of the commands I wanted to put in this slide just to give you the idea how these commands look like. So you might notice, most of the commands are within the address HWS, which is a hardware services environment. And when you code any of the OpsRex environment, you can use those commands. As in first example here is to get the attribute. So it's basically you are displaying the hardware properties on the target CPC, and you are getting those attributes back over to as an output in your EDQ, which is XML data queue, as an stem variable in the rex, which will retain it, and then you can perform any sort of operation on those attributes which you have got from your target CPC. You also may like to update some of the hardware properties on the fly or dynamically. And that also can be done using the second command, which is what listed on the slide, where you can perform the set attribute and any of the attribute, like, if you like to change the capacity for the image or the weight for the image, using the command, you can change the weight on the image using the OpsRex itself. Now, it's not just getting or setting the attributes. You can also send the commands across over to the CPC complex, and that's what the third command talk about. How do you control those events is also what I have listed as in fourth command. So if you need to make the changes, disable, enable the events capture, or getting those events using those dynamic commands, you can enable or disable the events back to the mainframe or the OPSMVS within the OPSMVS. Now, here comes the some of the use cases which I have taken as in just to showcase and correlate the BCPII functionality using the OPSMVS. So it's very common when it comes to the people who log into the support element and perform those operations on the hardware. They are considered to be the privileged users. And the reason they've been considered as the privileged users is because not much of those activities which they perform on those um, servers get recorded. Um, and, and and the impact is huge when it comes to any of the hardware changes which get done on those CPC complex. So here you can see as one of the example where if we have this OpsMVS BCP II version 2 as an example enable, um, when any of the privileged user log in to the support element, um, this event get created as a security event and get passed over to the ops log, which is where you can see if I move my cursor, a user logged in with this, from this location. Of course, you can see I have hided out the IP address, but you will be having exactly the IP address from which this user has logged in. And underneath, any of the operation which get performed by this user after logging in will be logged in as well. And those events will be captured back over to the ops log here. Um, this is a continuation from the previous slide where the user logged in. And here you can see the user logged off. So of course, with this sort of events, you can see what time, from what IP address, on what CPC, on what image, um, the actions were performed, or what sort of actions were performed by the users, and what time the user logged off. So it's give you the clarity in terms of what has been done, by, or what's been performed by this user within the duration that user was logged in. And that's certainly very important. As I said, those users can bring up great impact in the environment if those are not properly managed. And there may be a situation where you can probably have a code, the API rule in the OpsMVS, which can generate the alerts for the management, so that or the stakeholder who need to know exactly what time this user logged in and what actions were performed. So a different uh, needs can be fulfilled with the different way as long as these events are captured and forward over to the ops log. Um, the other example of the use case is some of the actions which happen automatically within the HMC environment or the support element environment is performing some hardware activities like copying the logs, between the primary and the secondary support elements or the alternate support elements. In those activities, if they fail, you might be having a situation where the data is not being captured. And you like to be aware about those situations if they occur in the CPC. And those, with this OPSBCPii, you'll have those capabilities where within the CPC complex, and not just one CPC, but if there are many CPCs with one OPSBCPii, you can monitor all the CPCs which exist in the CPC complex. So one of the benefit I said is single pane of view. You will be having a single pane of view for all of the activities which is happening in the CPC, and you can as accordingly as per your environment need can code those rules so that you can have the better visibility in your environment how things are running. Okay, so a quick summary. So OpsMVS BCPii can be used to capture the hardware events and the software event and can package them to perform the actions. OpsMVS BCPI can be further used to capture the security events and operation system messages to give you the better visibility and act in a real time. Further, as required, BCPii or OPS BCPii can be used to retrieve the system attributes, update those attributes, execute the hardware commands, and the retrieve system attributes can be further used for data analysis. Like I said, some of the customer like to retain them for a longer period so that they know what changes has been done within the CPC complex. Okay, so fairly quick, some of the use cases which I wanted to cover and the topics I wanted to cover within this session. And Angie, if you're still there, I'm okay to take the questions now.
Yeah, I'm still here. Thank you for that. I don't see any questions in the chat, but everyone should be able to unmute themselves if they have any questions. So if you have any, please please
Uh,
ask.
s- so hi, this is Yogesh. I do have a question. So hi Ravi. So do we have any kind of red book available to do this setup in our current environment?
Yes, we do, Yogesh. And thank you for asking that question. I should have included, there's a tech docs, which is having the examples given as well, which you can use to configure in your environment.
Okay, and I can find that on Broadcom site.
Yes.
Okay.
Do we have any other questions?
So just one more question. So we use ACF2 as a security product in our environment, and so as you said, this configuration can be used to monitor all kind of activity which user is doing when user is logged into mainframe, like any file transfer, file access, everything will be captured, right?
So it's more the use case which I've taken is from the support element. So if you log into the HMCs or support element on the hardware side is what being taken as an use case here.
Okay.
So it's irrespective of what ESM you use, whether it's a top secret or ACF2 or RECF.
Okay.
Okay.
Do we have any more questions? So you should be able to unmute yourself. If not, I wonder, Ravi, if you can show the final slide, which should have the QR code on, I think, for feedback. So please complete the feedback when you've got a moment, maybe right now, because it helps us, as I said earlier, helps us to know what we're doing right and what we're doing wrong, and hopefully give you what you want, so you get what you want out of this conference. So if there's nothing else, no more questions, then I'd just like to thank you, Ravi, again, for supporting GS UK and also the attendees. And I'll just let you know the next session in this stream is 8H, Defend Yourself Against Logical Data Corruption with GDPS LCP Manager, if you're staying in this work stream. Otherwise, there's lots of others to choose from. So thank you all once again. Thank you, Ravi. Have a good day, everyone.
Thank you, Angie, and thank you everyone for your time.